Alright, so I've been assigned problem 4, which is a square coil of wire 1 meter on each side has 14 turns, loops, and carries a current of 0.4 amps. It is free in a uniform magnetic field of B equals 2 Tesla, and if it starts from rest, which is a key term in this question, in the position shown in the diagram, then what is the maximum kinetic energy, another key term, that the loop will possess in its ensuing motion? Now, with these terms that we've seen in the question, we can determine that we're just going to use the conservation of energy equation shown here. Considering it says it starts from rest, we can determine that our kinetic energy initial is going to equal 0. Then, using equations given to us, the potential energy initial is going to be negative mu b cosine of theta initial. This is then equal to the potential energy final plus the kinetic energy final, which is negative mu b cosine theta final plus potential energy final. Solving for our final kinetic energy, we're then giving the final kinetic energy equals mu b, as we pulled out from these two equations, cosine of theta final minus cosine of theta initial. This mu b also equals NIAB, which can then be multiplied by 1, considering we're giving our A vector here to be perpendicular and pointed in this direction using the right-hand rule. And we want this A vector to be parallel to this B vector in order to maximize the kinetic energy. So, cosine of 0 equals 1 minus cosine of this initial 115 degrees. And we can plug that in using n equals 14, I equaling 0.4, A equaling 1 squared, and B equaling 2. We then multiply that by our 1 minus cosine of 115. We're then given our answer of 15.93, which gives us C.